Hi, this is Dr. Hassan Abdullah with the course Introduction to Natural Language Processing, and we are the video lecture 7A because the topic is number 7 named entity recognition. And this is the basics of this topic, so the lecture is 7A. This video lecture uses the supplemental material available at ezmcq.com/goget. So that source is a learning management system and it has wonderful features which allow you to personalize your learning experience. So the details are on the screen, and these are the videos which explain how you can make the most out of that learning management system. This is the outline of the course and the topics, and we are at the seventh topic, which is the named entity recognition. Now let's move on to the supplemental website. So we are at the supplemental website with number of core courses and cutting edge courses, which you can check. So we move on to the course which we are doing right now, which is natural language processing. And this is the table of contents of natural language processing course. And these are the topics. And we are interested in topic number 7, which is named entity recognition. So I click on it and I see that there are 17 questions with their answers. And let's start with the first one. So the first question is, what is meant by sequence tagging or sequence labeling? So it consists of number of tasks. So basically assigning a label or a tag to each token or the element. All right, so that is the one of the requirements of sequence tagging. But the things become challenging because we have to identify and classify different elements within the sequence. That is the challenging thing. So once we are able to take care of those challenges, then the commonly used task for sequence tagging is part of speech tagging, which we already covered, and named entity recognition, which we will be covering in this video, and of course chunking. So what it does is that it provides structured information. And what is the purpose of that structured information? Enabling downstream tasks. The tasks which follow the sequence tagging, such as machine translation, such as information retrieval, such as sentiment analysis, such as text generation, all of these are the downstream tasks. So all of this kind of runs those tasks, fuels those tasks. So let's look at the description of that question. And the answer description is, so what does it consist of? Assigning a label or a tag to each token or the element. Okay, and of course identifying the different elements also. So what is named entity recognition is in a sentence. So we have an entities, which is something which is of significance to the business as not as in trading but in the domain. And we would like to identify the type as a which is the person, which is organization, which is location, and which is what. For example, a location could be Paris, and a person could also be Paris. So this is not something very simple. And in the part of speech tagging, which we already covered, so we would like to identify an element or an entity or a token as a noun, verb, or adjective. And chunking is, what is chunking? Contiguous sequence of words, okay, that has a syntactic phrases, okay, such as noun phrases, or verb phrases, and so on. So, for example, if I ask a question of chunking, for example, what purpose of cars? So chunking basically runs and reaches to the point where the answer is transport. So this is not like a rule based. This is basically NLP running inside AI. All right. So let's move on to some of the examples of named entities. So what is an entity? Specific type of word or a phrase. That is an entity. Okay. And usually the entities are nouns or noun phrases, noun as a name of a person, name of a place. And I will also give you the some examples of entities also. Of course, entities are not limited to only nouns. And the objective is very challenging and very very fruitful also, and very bountiful and very rewarding also, when we can extract structured information from unstructured text and data. It has many valuable use cases which I will cover. So the description of the answer is, for example, specify a word, okay, type of word or phrases. And what do they represent? Distinct individual object, location, organization. I gave you the example of Paris, so it should distinctly identify that this Paris is a person and this Paris is a place. Okay. There could be other Paris also, like plaster of Paris. And then named entities are typically nouns or noun phrases. Okay. And they have generic concepts also. So let's look at some of the examples of named entities, like person Abraham Lincoln, person Muhammad Ali, great boxer, organization Microsoft, United Nations, location New York City, date, date is an entity, okay, time is an entity, product iPhone, Centro or from Hyundai, events, okay, events, Olympic Games is an entity. So why these entities are important? They are crucial. Why? Because they extract structured information from unstructured text data. I'll show you some examples also. And it has various NLP applications, which I mentioned, like question answering, text summarization, sentiment analysis, and they add value to the text also. So, what is named entity recognition in natural language processing? So we know what is entity is, and we briefly touched upon NER. So, identifying the entities and classifying them also. So it's not only identifying the entity, but classify that this entity belongs to which class. And locating and categorizing the entities. And locating, basically, if it's a document, then identifying, okay, this is the entity, and it belongs to this category. And this is essential to natural language processing. Why? Because it helps in information extraction, and it helps in document processing by humans also and by machines also. So we know what is named entity recognition, and the goal is to locate and categorize specific entities. Locate and categorize, and of course helps in extracting relevant information from text documents. So this is one example. I'll show you more examples also. So this is the legend, so to say, or the key. So this purple color is a place, okay? So American, right? And then of course we have this is why this is other, because we have African American, and we also have United States Senator, all right? But something which is very clear is location. So the United States is very clear, okay? And Illinois is very clear there it's a location. And then is the organization. So we have the organization as the Democratic Party, Illinois State Senate, and so on. And date is clear, August 461, and so on. So you see that this is how the named entity recognition is supposed to produce the results. So what is meant by named entity tagging? What does the tagging means? This is kind of repetitive, identifying, classifying named entities, okay, providing the structured information, right? And the label should indicate the type of named entity. For example, if you look at this statement, all right, so let's look at the explanation also. And it has several downstream applications. So if you look at this statement, so the named entity tagging system would identify this as a person, this as a place, this as a location, and the date also, okay? And the applications are already mentioned. So why should we be doing entity recognition, named entity recognition, in addition to supporting the downstream task? Because for information extraction, we need to extract the information from the document, and we maybe need to classify the document based upon that information extraction also. We increase the readability of that document, and text understanding and analysis. So not only the text is extracted, but the analysis of that text add value to the document itself, and improving the search and retrieval. So we have a large corpus of documents, right? So this name entity recognition allows us or the machine to effectively search and retrieve from that corpus. So information extraction of structured information from unstructured, okay, and it has various applications including database population also. So once we know that this is place, and this is a person, and this is time, and it was unstructured free text, so this NER allows us to extract the entities and populate a database. So this basically cuts down on the data entry time significantly, and it also cuts down on the errors, data entry errors also. So another application is helps in understanding the context and the semantics of text document, because in many cases understanding the context helps in disambiguation of the words, and it helps in establishing the relationship between the words, okay. And what it leads to in the downstream, it leads to sentiment analysis, document summarization, topic modeling, and so on. And of course improving the search and retrieval, okay. So let's move on. So, give us a use case of NER in healthcare medical system. This is very interesting and very very important also. So, say for example, we have we have some document, okay, and we can have multiple documents also, and which are related to healthcare. And these are the questions in which we are interested. And remember, it is free text. It is free text, and there can be different ways of presenting the same thing. So these are the questions we are interested in: detecting the COVID-related clinical terminology from a healthcare medical perspective, detecting clinical entities in the text. You can read them, and of course there can be more. Okay, so let's look at, so what it will do is, this system is going to this model. So this is basically this machine learning also. And there are other ways. There, it is rule based, it is dictionary based, it is machine learning based. We'll cover all of them very briefly. So the objective is to properly identify the systems. Okay, is to properly identify the system symptoms. I'm sorry, identify the symptoms in the documents. Okay, and diagnose their disease depending on the symptoms. Okay, so in this particular example, we want to identify the terminology, clinical entities, and so on, which is on the screen. So let's take a look. So let me zoom in. Okay, so it will be more readable. So this is the scenario here. So for the trials, and this is the sample text. Okay, and what we are interested in the age and the dosage. So this, the text is annotated by the machine, and it identifies the entities, and it highlights the entities in the text. Okay, this, there's no backend database, remember. So we have the age, and this color coded is as the what was we are interested in the dosage. Okay, so let's move ahead. Then we have another sample text here, and the objective was to identify the problems and what was the treatment. So the chest pain, diabetic, coronary artery disease problem, and the treatment was aspirin. Okay, and the treatment, of course, this treatment, this insulin is not for chest pain. Insulin is for diabetic, right? But the way the text is made available, the way this is processed. Okay, then we select another sample test. Okay, and the text is annotated by the machine. Okay, by what is ADE, this is medical terminology, and then we had the drug use. So this is of tremendous use to healthcare professionals, and the use cases are not limited to healthcare. They have diverse applications. Now, if this is so much fun and so much useful, then why it is not in use a lot? The reason being that it is not easy. It's challenging. And what are those challenges? First of all, is the ambiguity itself. So ambiguity is one of the biggest problems of natural language processing. And then is the variability in the terms. Okay, and of course there are rare entities. So rare entities which occur less frequently. So in terms of dictionary based NER, or rule based NER, or even machine based NER, so there is less learning by the machine, and there are fewer rules, or maybe the rules don't exist. Out of domain data, so the data which you come across is not a rare entity, but does not belong to that domain. So there's less training, and there are overlapping entities also, and data sparsity. So let's look at them. This example of the apple with the uppercase A and lowercase a. Okay, so is this a fruit or a technology company? So there's disambiguation, so it can be understood based upon the surrounding context. Okay, which can be complex, and which, and but this is not so simple. For example, the glass fell on the floor and broke, and the hammer fell on the floor and broke. And we know that in the first case the glass broke, and we know in the second case it was the floor that broke. So there is no context. It's not that simple. Variability. So we have New York City, fine, Manhattan Island. So we have NYC, we have this, and we also have the Big Apple also, and of course the Manhattan Island also. So which one is being referred, and they are the same ones or the different ones. So this is not the trivial. Rare entities. Some things which are not present in the training data, which are not domain specific, right? So that is which we already looked at. And then is overlapping entities, right? Where one entity is part of another. For example, the phrase boxer Muhammad Ali or Muhammad Ali is the same person. Okay, and it's also part of the larger entity boxer Muhammad Ali, right? So it, so to be able to identify that, it requires sophisticated modeling techniques. And data sparsity. The data may be scarce for specialized domain, and unseen data, and will resulting into in suboptimal performance. So how does named entity recognition actually works? So it consists of seven steps. Somebody could say like 4 steps or 5 steps. So some people or some authors combine the steps. So but overall, this is the basically the spirit of the NER process. So first of all is the data collection. Okay, and then is the tagging, right? Or the labeling, right? So that takes care of issues of like noise and formatting and inconsistencies, and then the subsequent work is based upon this data which has been collected, and tokenization, which we have covered in detail, and then the feature extraction. Okay, so the features could be word level features, which is token itself, contextual features like the bank was crowded, so the bank was crowded, so we need to look at the words and surrounding words, whether the bank was a river bank or it was a financial institution. Part of speech tagging, which we already covered, so which is a verb, which is action. So Google is a verb or a noun, book is a verb or a noun. Okay, and word shapes, capital US or in lowercase, and word embeddings for deep learning models. Okay, so we train the model, and this training common models are support vector machines also, and deep learning models like LSTMs and BERT, which we will cover in the deep learning course, and named entity recognition, which we need to do. Okay, and after that has been done, then it's post processing. So the initial prediction and the post processing may be applied. This could involve resolving the ambiguities of multi token entities such as New York, or fine tuning the output using additional rules or models. So after NER is done, it is not done. So okay, it is not done, it is done. Okay, it's not over till it's over. And then is the evaluations. Then the metrics like precision, recall, and F1 score, which are not limited to NER. Okay, so this is this. Let me clear this for you. So this is a diagram which basically shows part of the NER process. So what are the standard algorithms for named entity recognition? So the standard algorithms can be more also. For example, rule-based systems, so the human-crafted, handcrafted rules, machine learning algorithm, you train the model, and hybrid approach, which is a combination of them, statistical parsing techniques using statistical techniques, as there's no little or no machine learning, and unsupervised and semi-supervised learning. So if you look at the details, so the rule-based are handcrafted patterns or rules, okay, and to identify the named entities, linguistic patterns, right? And regular expressions are used, string matching, grammar based rules. So rules are there, and but the problem is that they lack robustness. Okay, and they are problem having with variations or unseen patterns. Then are the machine learning, which is sequence labeling algorithms are there, and we have hidden Markov models with conditional random fields. So we so these are the learn patterns and relationships from the label training data, which I mentioned earlier. All right. So then we have the hybrid approaches, always trying to get the better of the both worlds to improve the accuracy and robustness, right? Okay. And basically, what this so basically to refine the output of rule-based systems. So once we have that output, then improve upon it. Statistical parsing techniques, okay, dependency parsing, which we already covered in, I think it was section number or 6. So we have a clustering algorithms, topic modeling, and so on. So there's a lot of exciting things which have been done or can be done. So how does a dictionary-based NER system works? So let's look at it. So let's look at the question number 10. How does a dictionary-based NER system works? So it's a fairly simple approach. It's mostly a manual approach, and has limited application. So text pre-processing, basically we compare a dictionary of entities, and we assign them the tags, and that is basically entity identification, and then the entities are classified, and the results are done, and they are basically analyzed. So we start with dictionary creation. So compiling dictionaries of named entities, okay, various categories such as persons, organization, location, and dates, and then they are typically curated manually, okay, and so where we get them from, we get them gazetteers and knowledge bases, existing databases, and tokenize into words or phrases, unigrams or bigrams or trigrams, okay, and so that they are more manageable. And then we compare them against the entries in the dictionaries, and if it is there in the dictionary, then we label it, and it is a named entity. Okay, so what we do next is post processing. Now these additional post processing steps are performed so as to refine the results, okay, and resolve the conflicts between the overlapping entities. And finally we have the output generated, okay, with each entity identified with its corresponding category or label, and so on. So this is all I have for the basics of named entity recognition. Thank you very much.